Okay, this is a review of the code that we went over in class with the advisor class, the student class, and the grad student class. The grad student publicly inherits the student class. So the grad student is a student. We say that this relationship is an inherited relationship and is a relationship. We also talked about the fact that the grad student has as one of its data members an advisor object. So this advisor object, advisor name, is actually an object of the advisor class. That means that the relationship here is a composition relationship, has a relationship. Has a means this graduate student class contains an object of another class. Listen to the English of it. The graduate student has an advisor. So has a is different from is a. Has a is composition. Is a is inheritance. Okay, so let's talk about some of the things that's going on in the advisor class. So in the advisor class, we simply have a default constructor that will set the name to no name, and then we have a setter and getter function to get the name and set the name of the advisor. And of course, the data member is simply a name for the advisor. Notice this is a public and a private section. So in class, we talked about that if a class thinks it's going to be a base class for another class, it should make this section a protected section. Again, protected section is a blend of public and private. It says that any derived class, friend class, or functions have access to me, but the client still does not. And when I make a protected section, I'm setting it up for inheritance, which brings us to the student class. So the student class has a public and protected section. That protected section is an indication that we're probably going to have inheritance going on here. Now let's look at some of the functions for the student class. In the student class, again, I have a constructor that sets the name of the student. I have an add course function that adds a course. I have a get hours function and a get GPA function. So in the student class, I have this right here that will be inherited into the graduate student class. When I say that, I mean all three of these functions will not exist in the graduate student class, yet they will be a part of the graduate student class because the graduate student is a student. So all of these functions will be inherited. These next two functions, one called get check-in date and the other one called write student, are a part of the base class, but you see they have been redefined down here in the derived class. So in the derived class, to redefine a function, you simply give the same prototype, same function signature as the function in the base class. So both of these have the same signature as their counterparts in the base class, which means these are being redefined. We talked about three things that can happen to base class functions. One, they can just simply be inherited. Two, they can be replaced by redefining them. And in this case, get check-in date is being totally replaced by get check-in date in the graduate student class. Get check-in date in the student class is simply returning not specified, right? Get check-in date in the graduate student class is returning the date that the graduate student needs to check in. This function right here is replacing this function in the derived class. It's redefining it, but it's also replacing it. The third thing we can do is we can extend the function from the base class. So in the base class, we have write student, and in the derived class, we also have write student. The write student in the derived class is going to actually do everything that the write student in the base class does by calling on it, and then do a little more, because the grad student is a student that also has an advisor and a GRE score. So these two things will also be printed out when we have the right student function invoked. All right. Let me just talk about these getter and setter functions here. These getter and setter functions in the constructor for the derived class grad student have nothing to do with the base class. So the base class does not have access to get and set GRE. All right, so let's look at right student. Right student in the base class simply prints out the name, the semester hours, and the average, all the things that are in its protected section. So if I call on right student with a base class object, I will get all of these things printed out. If we look at the right student for the grad student class, we see that immediately when we get in the grad student class, we're going to right away call on the right student from the base class, the student class. So this is a call to this function because we have included the class name and the binary scope resolution operator to qualify it to say, call on the base class function and not call on myself. If I took away and just made the call look like this would be a call directly back to the same function, and it would just continually come in here and call itself, come in here and call itself, and get into a recursive loop. So by adding this scope resolution operator, we're saying go up here, print out all the information for the base class, and then come back and print the remaining information for the derived class. Now subtly, notice here, when I print out the advisor, I have advisor name.getName because I am in fact, as a grad student, a client of the advisor class. I do not have direct access to a name. If I want to get a name, I have to go through the getter function to get it. So advisor name.getName will give me the advisor's name. How can I get around that? Well, we talked about this in class. I could actually add to the advisor class a notation that simply says friend class graduate student. This would now give me, okay, this is supposed to be lowercase. This would now give me direct access to this private data member. So my call here would not even have to be a call. It would simply just be a name. I would be able to print out that advisor's name by using the object and accessing it directly. In this case, we're really not gaining anything, so friendship is probably not a good thing to have here. So we will just stick to calling on the getter functions. So that's a right graduate student. The other thing I talked about in class, when you instantiate a graduate student object like this one right here, the advisor name is Adele and the student's name is Stacy. When this instantiation happens, the graduate student constructor is called. When we call on the graduate student constructor here, notice there's this notation right here we call a member initializer. That member initializer is actually a call to the student constructor sending that student's name. So we would go up here, send the student's name, and initialize the other two data members, semester hours and average. And once that is completed, we would then come back and execute the constructor of the graduate student class. So the order of execution here is to call on this, preempt it, go and execute the constructor for the base class, and then come back and execute the constructor for the derived class. Also notice here again, because I don't have friendship, I have to go through the functions to pass this parameter on to the set name function to set the name of the advisor. Okay, so here we have a little code here that kind of shows what's going on when you instantiate a student object versus a graduate student object. But this code is actually in your folder and you can execute it yourself. Okay, so we add courses to the graduate student object. We have a base class pointer here pointing to a derived class object, what we're going to show here is that that base class pointer only sees the base class part of it. Okay, and down here we have again a call to check-in date with the graduate student object. That should show the actual check-in date. And then we have a base class pointer, and we're going to point to that same object, the graduate student object, but with a base class pointer. And when we do the check-in date there, it should say, hey, I'm only a base class pointer, so I only see the base class function. Let's run it and see what happens. So by the way, when I run this program, it gives me an error. This kind of error here, I'll say whenever I see there was an error, I always want to say no to errors. This kind of error right here has been popping up in Community 2017, and it has something to do with this GDI32.lib, okay? To fix this problem, all you need to do is go to Project and then retarget the solution. Click OK, and now that thing will run perfectly. So I'll click here, build it again, and as I run this, a lot going on here that I won't talk about too much, but if you look here at the bottom, the first day with the graduate student specifies August the 15th, but when I point to it with a base class pointer, because again, we've already discussed virtual functions in some of the other videos, this is not a virtual function, so it only sees the base class part of it. It does not see the derived class part, and it prints not specified. So that's the video on the student, grad student, inheritance example.